in problem number 4, we're going to prove that the limit of 3x minus 1 as x approaches -3 is equal to -10. And we will be using the epsilon delta definition of limit to prove that this is true, that the -10 is the limit of the given function as x approaches -3. So let's write our proof. Okay, and for step number 1, we're going to find delta. All right, so to find delta, we let epsilon greater than 0. Okay, and we want to find delta which is greater than 0 such that, all right, the absolute value of x minus -3 is greater than 0 but less than delta. Then, this is if, right? Then we should be getting the absolute value of 3x minus 1 minus -10, right, is less than epsilon. Okay, so again, at this very moment, we will be looking for delta. And for us to find delta, the value of delta, now we will be using the given expression, which is the absolute value of 3x minus 1 minus -10, which is less than epsilon. And for us to find the value of delta, we need to express it in terms of epsilon. And to do that, we need to express this in terms of this. Okay, so we will be starting from this inequality. So we have the absolute value. Let's copy the absolute value of 3x minus 10 plus, 3x, let me erase. Right, 3x minus 1 plus 10 is less than epsilon, correct? And let's simplify. 3x plus 9 is less than epsilon. And here, again, let's go back to the expression that we would like to express this to. And let's simplify this so as we will not be having some problems later. So this would be x plus 3 is less than delta, but greater than 0. All right, so we are supposed to express this inequality in terms of this, x plus 3. And to do that, we can factor out 3 here. So that's 3 times x plus 3, all right, is less than epsilon. And we have already shown the x plus 3, all right? We have already found the x plus 3 here. And since we're just looking for the x plus 3, we can factor out 3, all right, in the absolute value. So that's absolute value of 3 times the absolute value of x plus 3 is less than epsilon due by the property of absolute value. Okay, so the absolute value of 3 is 3. So x plus 3 and epsilon. And we have already found x plus 3 and x plus 3. And we don't need the 3 here, so we need to divide this by 3 both sides. So we have x plus 3 is less than epsilon over 3. So therefore, we could say that delta is equal to epsilon over 3. And how did we arrive at delta is equal to epsilon over 3? It's because we have already shown we have already expressed the left-hand side of the inequality, which is the absolute value of x plus 3, and this one is x plus 3. This is less than, all right, and this one is also less than. And what we have on the right-hand sides of the inequalities are delta and epsilon over 3. So we could say by inspection that delta is equal to epsilon over 3. And please remember this value of delta for us to continue our proof for this problem number 4. Okay, and let's proceed to step number 2. Okay, in step number 2, this is now the formal proof of this, or in this problem number 4. So we are going to show that, okay, let me just state first, or write the statement. So for every, according to the given definition, all right, oh, let me use white. All right, for every epsilon greater than 0, there exists delta greater than 0, such that if, okay, we are going to use this, if the absolute value of x minus -3 absolute value is less than delta, and of course this must be greater than 0, then what will happen? Or what do we get when we have this? We will get the absolute value of 3x minus 1 minus -10 is less than epsilon. All right, so with this given, okay, this is the premise of the given statement, and we need to show that the conclusion is true. We need to show that this is true using the given. So we will start from the given premise that says, okay, the absolute value of x minus -3 is less than delta. Oh, by the way, before I forget, we know that delta here is equal to epsilon over 3, right? We have found that a while ago in step number 1. So, oh, I forget the closing symbol for the absolute value. So here, we're going to start with this statement, and we know that this is greater than 0. But then again, this is always greater than 0 because we are an absolute value, okay? And at the same time, x approaches to -3, which means x can never be equal to -3. So therefore, it can never be equal to 0. So we could say x plus 3 by simplifying is less than delta. All right? Now, again, we want to express this in this form for us to prove that this limit of 3x minus 1 as x approaches -3 is equal to -10. So how do we do that? Now, again, look at the x here. X has 3, so we can multiply this by 3, okay, or absolute value of 3, so as we could multiply them together later. Okay, so we have absolute value of 3 delta. And let's move it here. Oops. And here, so we have, let's multiply now. We have 3 times x plus 3 is less than 3 delta. Again, oh, the closing symbol. Okay, so we have this, and we can now simplify this, or by factoring, sorry, by multiplying 3 and x plus 3, we have, oops, we have 3x plus 9 is less than 3 delta. Okay, again, we are supposed to express the left-hand side in terms of this expression. Now, how do we do that? So first, we express it to 3x minus 1. And since we have minus 1, so therefore this becomes 10, right? Okay, this becomes positive 10. So plus 10, 3 delta. However, we need to express 10 as negative numbers. So we have 3x minus 1 minus -10 less than 3 delta. All right, so we have already expressed the left-hand side in terms of this. So we are good to go now. Now let's proceed to the next slide, and let's recall this last step. Okay, we found that 3x minus 1 minus -10 close is less than 3 delta. Let's check. Okay, that's right, 3 delta. And we know that delta is equal to epsilon over 3, right? So let's substitute. So this becomes the absolute value of 3x minus 1 minus negative 10 is less than 3 times epsilon over 3. And I can cancel out 3 here, so this becomes epsilon. So we have 3x minus 1 close minus negative 10 is less than epsilon. So we have already proven that this statement is true, that the absolute value of 3x minus 1 minus negative 10 is less than epsilon. So since we have proven that that is true, therefore we can now say, and we can now conclude that the limit of 3x minus 1 as x approaches negative 3, okay, is equal to negative 10. So this is now the final step.